Trigonometric substitution case 1. So this time we will be working on a definite integral. So in this definite integral, do you see that I am not using any numbers? I replace the constant with an a, and this is x goes from 0 to a. So if you take a look at the radicand, that is a squared minus x squared. So that is case 1. In case 1, we have to let x equals to a times sine of theta, and then of course to rewrite the dx, we have to take the derivative on both sides. Let's do that. So the dx is equals to, the derivative of sine is cosine, right? D theta, and that is going to go right here. So this dx is going to go right here. So other than the dx, we have an x squared. So x squared is equals to a squared times sine square theta. And then we also have a square root. So the square root, we can do this. The a squared minus x squared. So that is equals to a squared. The square of the x, that will be a squared times sine square theta. So that is equals to a squared 1 minus cosine square, which is equals to sine square. And then you take the square root of that, that is equals to a times sine of theta. Oh, 1 minus sine square. Why do I put 1 minus cosine? This is a 1 minus sine square. So 1 minus sine square is equals to cosine. So this is a cosine, and then you take the square root of that, you have a cosine, a times cosine of theta. Okay, so a times cosine of theta, and then other than that, this is a definite integral. I am going to change the dx to du. That's why the a x equals to a and the x equals to 0 must be changed. So since I put that in blue, let's use blue. So we have x equals to a, so we call this x is equals to a times sine, right? So what happened when x is just a? Then you have a equals to a times sine of theta. So this is handling x equals to a. And then you have 1, right? So 1 equals to sine of theta. So how do we use the negative pi over 2 to pass the pi over 2? So where is this? In the unit circle, this is between quadrant 1 and quadrant 4. So between quadrant 1 and quadrant 4, how do you get y equals to 1? To get y equals to 1, we have to let theta equals to pi over 2. So this domain of theta is for you to change the x to theta. So this is for x equals to a. What about x equals to 0? So x equals to 0, we have 0 equals to a times sine of theta. So 0 is equals to sine of theta. So use the inequality again between quadrant 1 and quadrant 4. How do you get y equals to 0? The answer is the theta must be equals to 0. And then we do the rewrite. So when you do the rewrite, you have theta that is pi over 2, and this theta is from 0. And then we have an integral of that. So the x squared is now a squared times sine square. A squared times sine square theta. What about the square root? The square root is a times cosine of theta. What about the dx? The dx is a times cosine of theta d theta. Nothing can be cancelled, but we can do some simplification. So we have a squared, a and a, right? So that is a to the 4th from 0 to pi over 2. Sine square, cosine square. So we have sine square theta times cosine square theta d theta. This one we have to work something out. That is what makes this trig substitution difficult, and this is something you have to practice. So let me do that in a different color. So we have to use the double angle formula. The double angle formula for what? The double angle formula for the sine square times cosine square. So I'm going to use this one. Sine of 2 theta is equals to 2 times sine theta and then cosine theta. This is a double angle formula for sine. And then I am going to square both sides because I need a sine square and a cosine square. So this is sine 2 theta square equals to 4 times sine square cosine square. and then you divide both sides by 4. So you have 1 over 4 sine of 2 theta square equals to sine theta times cosine of theta. Forgot the square. And then you are going to replace the whole thing to here. All right, so let's do this. So we have, then this will be a to the 4th divided by 4 then. From 0 to pi over 2, we have sine of 2 theta, and then square. And then square, this one, the square, we can put the square right here, and then d theta. I can't just integrate like this. I have to do one more rewrite. So that will be the double angle formula for cosine. So let's do the job in a different color. So we have cosine of 2 theta. Yes, this is hard. That's why you have to do your homework. That's why you have to practice. 2 times sine square theta. And then we want to isolate the sine square on one side. So what we are going to do is I am going to how about this? We swap the 2 sine square and the cosine 2 theta. So 2 times sine square theta is equals to 1 minus cosine of 2 theta. And then we divide both sides by 2. That is equals to 1/2 and then 1 minus cosine of 2 theta. But we have a 2 theta in right here. How do we fix this problem? So all you have to do is you change the theta to a 2 theta. How does that affect the other side? That only affect these two. So that becomes 1/2 1 minus cosine. Now watch. This is 4 theta. How do we get a 4? It's 2 times 2 theta. These 2 is right here. These 2 is this 2. If that is a 3, then this will be 3 times 2 theta. This 2 theta is from here. So let's say this is a sine square 10 theta, then you have 10 times 2 theta. If this is sine square 60 theta, then you have a 60 times 2. Okay, so now let's rewrite the integral one more time. A to the 4th divided by 4, 0 pi over 2, and then that becomes 1/2 1 minus cosine 4 theta d theta. Then this you can integrate. You don't need any u substitution or by parts. A square, a to the 4th, 2 times 4, and then the integral from 0 to, oh, we don't need to do this anymore. What is the integral of 1? The integral of 1 is equals to theta. The integral of cosine is sine, so we have sine of 4 theta, but we have to prepare a 1/4 in front of the sine, because when you do derivative by chain rule, you have to derive the 4 theta. That gives you a 4. That's why you have to prepare 1/4 in front from 0 to pi over 2. This you don't even need the right triangle, because the right triangle is for you to go from d theta back to a dx. Since we are not having any more dx, we will just plug in, right? We don't have any more dx, we will plug in, and then the job is done. Let's do the plug in. A to the 4th divided by a, and then plug in the pi over 2. You have pi over 2, right? And then minus 1/4 times sine pi over 2 times 4, so that will be 2 pi. And then the 0, oh, the 0 makes everything 0. Let's write it anyway. 0 minus 1/4 sine of 0. So the whole thing is 0. So this one is just, what is that equal to? That is sine of 2 pi is equals to 0. Oh, easy. Then this is a to the 4th times pi divided by 6/16. This is the final answer. The integration is simple, but the rewrite, if you go back to take a look, the rewrite, the double angle formula, that is not too obvious, right? The one in red, in orange. That's why I picked this problem. That's why you have to do your homework. Trust me, when you are new to this subject, the first couple problems you solve, expect to spend a long time to do it, because this is not a short problem. Every integral in trig substitution is not a short problem. Be prepared to spend one full page to do one integral, and you have to do a lot of erasing, and you have to do a lot of correction, right? It takes practice. Okay, so that is the end of this video. If you think I picked the best problem for the discussion, give me a like, share the video for me, subscribe to my channel. See you all in the next one. Signing off for now.